Computer vision, image processing have been hot topics for a very long time. A lot of folks have derived a lot of value from computer vision with modern technology, with modern AI algorithms. Using them on computer vision has yielded amazing results. Now, given a lot of technology around computer vision and so much advancement being made in the field, oftentimes folks who are just starting to explore image processing, computer vision, get demotivated given the plethora of information out there, and they don't know where to start. A lot of folks come and seek advice on how we can get started with computer vision, image processing. I personally get contacted by a lot of people who want guidance on how they can get started. So this video, I'm going to give you a basic understanding of how to get started with image processing or with simple computer vision tasks, how to assess, how to understand what images from the point of view of a computer look like, and gives you some basic code and basic libraries that you can use to get started with image processing and with your computer vision projects. Welcome back to the channel, guys. My name is Dhruv. I'm an engineer at Convolve. And at Convolve, we assist small, medium, large enterprises with improving their operational efficiencies by leveraging artificial intelligence. You are looking to incorporate AI into your workflow. You want to get in on the hype, but you don't know where to get started. Well, here is the contact information. We are here to help you. We are here to assess your needs and help you get started with incorporating AI into your business. So coming back to the topic of this video, that is the basics of how you can get started on a computer with computer vision, with the basic image processing. So guys, let's go over this notebook that I've created and go over it step by step. So guys, here on the screen you can see a simple Jupyter notebook that I've created, and in this notebook I go over the basics of image processing. We're going to go over how you can load an image, what an image looks like when seen inside a computer, how it's stored. Then we're going to talk about how you can do certain operations on the image, and we're going to introduce OpenCV, which is one of the most important tools in image processing. If you are a beginner, it's going to help you a lot. So it's great to get yourself familiarized with OpenCV. So guys, let's first look at on the screen. So here is a sample image. This is an image that is very widely used in image processing. Almost every image processing class that you'll take will use this image. This girl's name is Lena, and this image has a lot of information, a lot of texture. You can see there are colors, there are a lot of edges here around her hair, which are essentially these feathers on her cap. All of this information is of course useful when teaching computer vision or image processing, and at the same time the image is amazing. But the reason it's used in image processing or in tutorials is because of the variety of information and the content that's there in the image that the algorithms love to look at. Now guys, going to our notebook over here, this is the basic Jupyter notebook that will show you how you can read an image and how you can perform basic operations, basic functions on the image in order to derive value. So the first thing here is we need to derive or import the necessary packages. So it's CV2 is OpenCV. OpenCV is a toolkit that has a lot of built-in functions for image processing. It can be used in Python and in C++, um, and it is very useful. Then we have matplotlib. This is for plotting purposes, to be able to plot graphs, histograms, you name it, matplotlib can do it. And then we have numpy, which is essentially for dealing and working with arrays. The first thing here is to read the image, and the function to read the image is very simple, cv2.imread, and you give the name of the image. This is going to read the image onto the memory. Now guys, the next step is we take the image and we convert it from BGR to RGB. Okay, so this line is essentially making a conversion. Now, why do we need a conversion? Is because when CV2 loads the image, when OpenCV is loading the image, it loads is it as blue, green, and red channels. And in most of the other libraries, for example, Matplotlib, when plotting the image, it expects the image in red, green, and blue channel. So this line over here is just making that conversion, changing the channels from RGB to from BGR to RGB. But before we go there, let me explain you how these channels work. So guys, what an image is essentially. An image is just a matrix. That's what an image is from the point of view of a computer, right? So we as humans, we perceive the world, right? And when a computer is perceiving the world, when a camera clicks a picture, that picture is stored as a matrix. That matrix, say the resolution of the image is 1024 by 1024 or 512 by 512. In that case, it means that there are 512 rows in that matrix and 512 columns, which with each pixel having some value that represents the intensity of that pixel in the image. Now, if the image is a colored image, it will have three channels. So here, for example, when we look at, if we do this image dot shape, you'll see that the image shape is 512 by 512 by 3. That means it has three different channels. So there are three matrices of 512 by 512. So three matrices of the size 512 by 512, which include the information about the red channel, green channel, and blue channel. Um, these channels have the information about the color in the image, and then when you plot that image, it will essentially showcase a colored image. Now, that is what an image is, and you can see here when we print the image variable out, it's just an array of 512 by 512 by 3, and it has all the information. These are all the values. These are integers from 0 to 255 that correspond to pixel values. Now, as I said, right, the three channel image is a colored image. If we want to convert into a grayscale image, all we do is we can use this particular function in CV2 in OpenCV, which converts the image from color to gray. So BGR to gray, and this is what it looks like. Now, if we look at the shape of the new image, the grayscale image that we've created, you'll see that the channels are gone. Now we only have one channel instead of three channels, and hence the image is now a grayscale image. Now guys, once we have this basic understanding of how the image is presented and how the image is stored in a computer, then comes further operations, right? So there are so many different things you can do on top of an image. You can do edge detection, you can do um, convolutions on top of an image to either blur an image or to extract more useful information out of the image. You can smooth an image, you can add noise to the image. So there's so many different things that can be done. We'll go over a few simple examples. One is edge detection, the other is how you can perform convolutions onto the image. Now guys, OpenCV has all these different built-in functions, built-in methodologies that you can leverage to do these things. One of them is edge detection. So guys, if we look at the formulation for edge detection, it is a mathematical formulation, and what it does is it goes over the image. This math is run throughout the image, and the output is the edges inside the image, right? So here over here we use the uh, cv2.canny, which is a canny edge detector filter. This is the canny edge detection filter, and this is the page in OpenCV that explains it along with the math. And when we run this, this is what we get. So this, as I was mentioning, the feathers on the cap, right? That's why that detail is important, because when this is being taught, when image processing is being taught, this image has all the details, the edges for students to learn from. Here you can see all these feathers as edges in the image, and this edge detector has actually taken a grayscale image and extracted all the edges from it. The second thing we're going to look at is convolution. So convolutions is something that is actually very important in image processing in convolutional neural networks in general. As you move forward with your computer vision or image processing journey, you will understand how important CNNs or convolutional neural networks are today in AI and vision, and this convolutional operator is the basis for it. So what is convolution? You have an image of say 512 by 512. You take a filter that is of a smaller size, maybe of a size of 5 by 5, and you move that filter over the image. And while you're moving that filter over the image, you are doing convolutions, which means you're essentially multiplying the filter values with the values of that window in the image and getting the output from there. And what we can do with that, we can do using convolution, we can cause some image smoothing, we can blur the image using different kind of filters. So there is an averaging filter which will basically average all the elements in that particular filter, in that filter window, which will give a smoothing, an averaging effect to the image, and it will cause some blurring on the image, as you can see the example over here on the screen. Now, similar to blurring, there's average filtering, average blurring, and then there's other types of blurring. And what changes is the filter. For example, in an average filter, all the values are the same in that particular kernel. However, in terms of Gaussian blurring, the filter is like a Gaussian distribution. So it does not just do an average smoothing. It does a little more complicated math on top in order to give you a better result. And similarly, we have median blurring, and then we have bilateral filtering, and there's different kinds of filtering. So let's look at an example for blur, which is essentially average filtering. And we've taken a window size of 5 by 5 for our convolutions. So the filter size is 5 by 5, and we run it over the image, and you can see the image that is the output. Now if you increase the size of the window, you'll see the blurring will increase. So I make the window size of 15 by 15 instead of 5 by 5, and here you can see the output is way more blurred as compared to before, which was at 5 by 5 it was way less blurred, right? So by doing this blurring, sometimes if there's noise in the image, you can get rid of that noise, and that's how this can be useful. And as I said, guys, this convolutional operators make the basis for CNNs. So if you are interested in convolutional neural networks, then understanding convolutions is a key, is very important as you proceed further. Now guys, that's it for this video. I just wanted to go over the basics of image processing and computer vision for those folks who kind of find it hard to get their foot into the door, who want a little nudge, who want some help to get started. This video was for you guys. You can use this notebook. It has been uploaded to the GitHub repository, and the link is in the description. You can use it to get started and to play around with different image processing and computer vision tasks. Computer vision is a very vast field. There's so many different things to cover, and in the upcoming videos we'll try to make a playlist on intro to computer vision to be able to cover different important aspects that you can use to get started with the computer vision and start rolling out projects, start making useful contributions with code and with this technology. Guys, if you found this video useful, please hit the like button, subscribe to the channel, and hit that bell icon so you are notified about any new video that we upload. We keep uploading content on latest and greatest in AI and computer vision. We also are looking to now create educational content around computer vision, around artificial intelligence. So if this is something of interest, please subscribe to the channel, and also share it with your friend who you think may be interested in this content. Thanks again for watching, guys, and I'll see you in the next video.